Okay, welcome back, chemistry students. Today we are on day 4 of our Unit 9 notes. We are going to be talking about volumetric stoichiometry and percent yield. So the first thing we're going to talk about here is volumetric stoichiometry. We're going to do some dimensional analysis, calculating with the volume of a gas. That is what volumetric stoichiometry is. And so this is going to involve a substance that is a gas. So if you have a substance that's a gas, that gas is going to be at something we call standard temperature and pressure, STP. So if you have this gas at standard temperature and pressure and you need to go to volume, we can use this thing called the molar volume conversion to get there. And that molar volume conversion, we have that listed right here. 1 mole of a gas is equal to 22.4 liters of the gas. This is also found inside your formula chart. So you do not need to memorize this. If you flip open your periodic table formula chart, that second page, under gases, we see that the molar volume at standard temperature and pressure is listed as 22.4 liters per mole. So that conversion is always available to you there. And when we go to write this in our dimensional analysis, we can write it one of two ways. We can put the liters, 22.4 liters of whatever compound or element we have, A, is equal to 1 mole of that compound or element, like that, or we can put moles on top. So 1 mole of a compound or element is equal to 22.4 liters of that compound or element. Again, for a gas at standard temperature and pressure. This doesn't work if you have a liquid or a solid. It has to be a gas. But you will set up your conversion in one of two ways, this way or this way, based on your dimensional analysis that you have set up. So as we move through our problems today, we're going to see that. So example 1 here, we are going to be dealing with the synthesis of water. We're going to do some calculations involving this equation. I'm going to go ahead and balance this real quick. If I put a 2 there, a 1 there, and a 2 there, I end up with a balanced equation. If you are still struggling to balance your equations, find yourself a chemistry teacher, get yourself some help. You do need to know how to balance for your quizzes and your tests, because we do need these coefficients in order to help us go from mole to mole in our dimensional analysis. So example 1, part A. Our first question is how many liters of hydrogen are needed to make 14.5 moles of water? So I like to underline what I'm looking for in this problem. We are asked how many liters of hydrogen are needed to make 14.5 moles of water. I also like to make myself a little map. So we're going to make ourselves a stoichiometry map today. I'm going to rewrite my balanced equation down here so I can draw some arrows and make sure I am mapping out where I need to go. So we know we have 14.5 moles of water. That's our given. So I'm going to write that underneath water here so I keep track of that. And I want to know how many liters of hydrogen. So that is our what we are converting to. So as always, before we can change, we're in moles right here, so that's good. Because we can get from moles to moles, we can use our mole ratio to convert from mole to mole. So right here, I can go from moles of H2O to moles of hydrogen. I can use that thing called a mole ratio. Or, in other words, we're going to have to use our coefficients, these big numbers up in front that we use to balance, to get from moles of H2O to moles of H2, hydrogen. And now we can use this handy-dandy molar volume conversion in order to get from moles to liters. So I'm going to make a note. This is molar volume. If you want to abbreviate it as MV for molar volume, you can do that. But that is the conversion that we are going to use to get us from moles to liters. And so I have drawn myself 2 arrows here. That means this is going to be a 2-step problem. So we're going to come over here and we're going to set up our dimensional analysis. I'm going to start with my given, 14.5 moles of H2O. I'm going to set up some train tracks. If you like to use parentheses, you can use those. And remember, whatever unit we have up here must be put down here. So what goes up must come down. I'm going to go ahead and put that unit down here. And we have mapped out our dimensional analysis here. So we've done all the work already. We just need to plug in some numbers and some units. So we're going from moles of H2O to moles of H2. So I'm going to put moles of H2 up here. And I made myself a note that my coefficients are what we are going to use to fill in our numbers here. So I see that the coefficient 2 is with my H2O. So I'm going to go ahead and put 2 for 2 moles of H2O. We need 2 moles of H2O for every 2 moles of H2. So there are our numbers filled up there. At this point, we have now, let me get a different color actually. We can show this. At this point, we have canceled out our moles of water. We are now in moles of H2. But we want to get to liters of hydrogen, liters of H2. So we're going to use that molar volume conversion. I'm going to go ahead and take this unit and put it down here. What goes up must come down. To get from moles of hydrogen to liters of hydrogen. And we wrote our conversion over here. We can write it one of these 2 ways. I see that the units match this one right here. So for every 1 mole of hydrogen, we have 22.4 liters of hydrogen. So that is our dimensional analysis. We will cancel out moles of hydrogen here, and we are left with liters of hydrogen. So we're going to go ahead and solve this. I'm going to put this into my calculator. Sorry, y'all, had to go grab myself a calculator. So we're going to go ahead and do 14.5 times 2 times 22.4. And then we're going to divide that by 2, because I have 2 on the bottom over here. So divide by 2. That's going to give me 324.8 liters of hydrogen. But I have to be careful, because over here, I was given 14.5 moles, which is a number with 3 significant figures. So that means my answer has to have 3 significant figures as well. So I'm going to go ahead and round this to 325, because that 8 is going to round that 4 up to 5 liters of hydrogen. So that is my final answer. Okay? So we're going to do another example. We're going to do part B down here. So I'm going to go ahead and, again, get myself some extra paper so I can show y'all that map as we go through this problem. Our question here is how many milliliters of oxygen are needed to make 6.432 moles of water. So again, I'm going to underline how many milliliters of oxygen, that's how much we are trying to figure out, are needed to make 6.432 moles of water. So right here, again, I'm going to write my balanced equation. So I can put my given values underneath each compound. I am given 6.432 moles of water, so I'm going to write that underneath water. And we want to know how many milliliters of oxygen we need to make that. So again, we're going to make sure we map this out so we know exactly where we're going. I can go from moles of H2O to moles of oxygen. We can convert between moles in our reaction. So one step, if I use a mole ratio, which is going to be created with my coefficients that I put in front of my compounds and elements, I can convert from mole to mole. Once I am in moles of oxygen, I can use that molar volume conversion to get to liters of oxygen. So I'm going to make myself a note here that I can use the molar volume conversion, this up here, to get from moles to liters. And then finally, I can get from liters to milliliters using a metric conversion. In this case, the metric conversion, that there are 1,000 milliliters in 1 liter. So that's the metric conversion we're going to use here. You will have these conversions. If we have you use a metric conversion, you will be given them on your quiz and test. But for right now, I want you to write that down so you have that on your notes. Okay. Now that we have created our map, we can go ahead and write out our dimensional analysis. Again, we're always going to write our given first. We have 2.432 moles of H2O. Remember, we always write our number, unit, substance to help keep us organized. I'm going to set up some train tracks. I'm going from moles of H2O to moles of oxygen here. So I'm going to go ahead and make sure I set up my conversion like so. I have moles of H2O right here. What goes up must come down. So I'm going to go ahead and grab moles of H2O and put it down here. And then I'm going to put moles of oxygen up here because that's what I'm converting to. Again, we're going to use our coefficients. We made that note here. We need to use coefficients to convert to make our mole ratio. So I have a 2 with my H2O. So I'm going to put a 2 right there. And I have a 1 with my oxygen. So I'm going to put a 1 right there. Now I'm in moles of oxygen. Now I want to get from moles of oxygen to liters of oxygen. I get to use my molar volume conversion. So if I put moles of oxygen down here, so my units can cancel, and I guess I should go ahead and show you. Your moles of H2O will cancel here. We're trying to get moles of oxygen to cancel right here, so that's why we're going to put moles of oxygen down there. And then up top, we can put liters of oxygen. We know that there are, in our gas here, 22.4 liters of oxygen in 1 mole of oxygen. And then finally, we have one more step because we drew 3 arrows here. We want to go from liters of oxygen to milliliters of oxygen. So I'm going to go ahead and put liters of oxygen down here and milliliters of oxygen up here. I just told y'all that there are 1,000 milliliters in 1 liter. So we're going to make sure that we write that there are 1,000 milliliters in 1 liter right there. And that is our dimensional analysis. So next up, we have to type this into our calculator. I'm going to do 6.432 times 22.4 times 1,000. That gets me this number. And then we're going to divide that by 2, because we have 2 on the bottom there. So we get this number, 72038.4. Okay? Again, we have to be mindful of our significant figures. So right here, I see that we have 4 significant figures in our given. So I want to make sure my answer also has 4 significant figures. So I can make this 4 significant figures by rounding this 2. And if you want to do this by yourself, pause me real quick if you want to practice. Otherwise, your answer is going to be 72,040 milliliters of oxygen. So there is your final answer for part B. Okay. Last but not least, let's go ahead and work through part C here. Part C asks us how many liters of water are needed to make 24.3 grams of oxygen. So again, I'm going to rewrite out my balanced equation so I can make myself a map. The map is going to help you know where you are going and cut down on errors. So we have our balanced equation. We are told we have 24.3 grams of oxygen. And we want to know how many liters of water we can get from 24.3 grams of oxygen. Okay? So, again, this is going to be a grams to liters. So this is going to be a fairly long one, another 3-step problem. So we're going to give ourselves plenty of room. Before we can get to moles of H2O, if we are in grams of a different substance, we always have to make sure that we convert to moles of that substance. Mole is our go-between. We can make ourselves a mole bridge, but we have to be in moles first. So I'm going to convert grams to moles, and hopefully y'all remember that you can use molar mass to convert from grams to moles, or moles to grams. Once we are in moles of oxygen, now we can we can make a mole bridge, and we can get to moles of H2O. Once we're in moles of H2O, we can use that handy-dandy molar volume, our molar volume, to get from moles to liters. So I'm going to draw an arrow from my moles to liters, and I'm going to write MV for molar volume. And if you would like to make yourself a note that you're going to need your coefficients, your mole ratio, in other words, to get from mole to mole, then do that. This tells me everything I need to do to set up my dimensional analysis. Okay? So we're going to go ahead and do that. We're going to set up that dimensional analysis and solve it. So right here, I have, starting out, 24.3 grams of oxygen. And I'm going to write my number, my unit, and my substance, 24.3 grams of oxygen. We're going to convert from grams of oxygen to moles of oxygen, as our map tells us to do. So this unit, grams of oxygen, is going to go down here. What goes up must come down. We're going to convert from the grams to that moles of oxygen. I gave myself a little note here that I need molar mass. I need the molar mass of oxygen in order to convert from grams to moles of oxygen. So over here, I'm going to make myself a little note. Molar mass of oxygen. Right here, I have 2 oxygen. And if I go to my periodic table, I see that oxygen's average atomic mass is 16.00. If I do 2 times 16.00, I get 32.00. That is my molar mass of oxygen, 32.00 grams per mole. So I can go ahead and put 32 with my grams of oxygen and 1 with my mole. In 1 mole of oxygen, we have 32 grams of oxygen. So there is step 1, that first arrow, and we have canceled out our grams. So we are now in moles of oxygen. We want to be in liters of H2O, so we still have 2 more steps that we have to fill in. So my next step, I'm going from moles of oxygen to moles of H2O. So I'm going to go ahead, take this unit, put it down here. We're going from moles of oxygen to moles of H2O. I'm going to use my coefficients, my mole ratio, to get from mole to mole. So right here I have the number 1 with oxygen, so I'm going to put that there. And I have the number 2 with hydrogen, so I'm going to put that there. that is step 2. We have now canceled out our moles of oxygen. We are in moles of H2O. We want to do our final step. We want to get to liters of H2O. So we're going to go ahead, take this unit, put it down here. What goes up must come down. And we are going from moles of H2O to liters of H2O, just as our map tells us. And we made ourselves a nice little note here that we need to use the molar volume to get from moles to liters. And our molar volume, as we saw earlier, is right up here. There's 22.4 liters in 1 mole. So I'm going to make sure I put 1 with the mole and 22.4 with liters. And now we can solve this. So I'm going to get my calculator. I'm going to do 24.3 times 2 times 22.4. If you want to go ahead and do this on your own calculator, make sure you're typing it in right. Go ahead and pause me before I give you the final answer. But we're going to then divide that by 32, because that's on the bottom down here. Hit enter. That's going to give us 34.02 liters of H2O. But hopefully you caught that our given had 3 significant figures. So you're going to have to round this to 3 significant figures as well, which is 34.0 liters of H2O. Our final answer. There's your final answer there. Okay. Once you're done with this, go ahead and watch the next video that has to do with percent yield, and we'll get y'all taken care of there.